Hello students, I hope all of you are fit and fine. So today we will start chapter number 9, that is areas of parallelograms and triangles. Suppose you have two figures A and B and these figures A and B are congruent, then we will say area of A is equal to area of B. For example, as you can see here, here is a figure. Let the area of the whole figure is T and area of the two sections are P and Q. So in this case we can say the area of T is equal to area of P plus area of Q. One important point is that if two figures A and B are congruent, then they must have equal area. However, the converse is not true. That means if two figures have equal area, they may or may not be congruent. But if they are congruent, they must have equal area. Now let's have some figures with the same base and between the same parallel. As you can see, four figures here. Now in these four figures, in figure 1, clearly trapezium ABCD and parallelogram EFCD are on the same base DC. In addition to the above, the vertices A and B of trapezium ABCD opposite to the base DC and the vertices E and F of parallelogram EFCD opposite to the base DC lie on a line AF which is parallel to DC. We say that trapezium ABCD and parallelogram EFCD are on the same base DC and between the same parallels AF and DC. Similarly, parallelogram PQRS and MNRS are on the same base SR and between the same parallel PN and SR, as you can see in figure 2. As vertices P and Q of PQRS and vertices M and N of MNRS lie on a plane PN parallel to the base SR. In the same way, triangles ABC and DBC lie on the same base BC and between the same parallel AD and BC, as you can see in figure 3. And parallelogram ABCD and triangle PCD lie on the same base DC and between the same parallel AP and DC, as you can see in figure 4. So what is the conclusion? The conclusion is that two figures are said to be on the same base and between the same parallel if they have a common base or side and their vertices or vertex opposite to the common base of each figure lie on a line parallel to the base. Now the next topic is parallelogram on the same base and between the same parallel. So for this we have one theorem. The theorem is that parallelogram on the same base and between the same parallel are equal in area. So as you can see the figure here, now two parallelograms ABCD and EFCD on the same base DC and between the same parallel AF and DC are given here. Now here you need to prove that area of ABCD is equal to area of EFCD. Now here in triangle ADE and triangle BCF we have angle DAE is equal to angle CBF. Why? Because corresponding angles from AD parallel BC and transversal is AF. Let it be equation 1. Again we have angle AED is equal to angle BFC. What is the reason? Same reason, corresponding angles from ED parallel FC, and which one is the transversal? Transversal AF. Let it be equation number 2. Therefore, we can say that angle ADE is equal to angle BCF Because of angle sum property of triangle. Let it be equation number 3. Now AD is equal to BC. Why? Opposite sides of a parallelogram. That means opposite sides of the parallelogram ABCD. Let it be equation number 4. So now we can say that triangle ADE is congruent to triangle BCF. Why? Because of the congruency criteria ASA. Okay, and also we are using equation number 1, 3 and 4. So therefore we can say that area of triangle ADE is equal to area of triangle BCF. Why? Because the two triangles are congruent, that means their area must be equal. So now we can say that area of ABCD is equal to area of ADE plus area of EDCB, or area of BCF plus area of EDCB, as you can see this one from equation 5. Therefore, this one is also equal to area of EFCD. So, parallelogram ABCD and parallelogram EFCD are equal in area. Now, let us take one example. The example is, if a triangle and a parallelogram are on the same base and between the same parallel, then prove that the area of the triangle is equal to half of the area of the parallelogram. For the solution, first of all, let triangle ABP and parallelogram ABCD are on the same base AB and between the same parallel AB and PC. You need to prove that area of PAB is equal to half of area of ABCD. First of all, here BQ parallel AP is drawn. Now, parallelogram ABQP and ABCD are on the same base AB and between the same parallel AB and PC. Therefore, area of ABQP is equal to area of ABCD. Why? By theorem you all know. Then we have triangle PAB is congruent to triangle BQP. Why? Because diagonal PB divides parallelogram ABQP into two congruent triangles. So, area of PAB is equal to area of BQP. Let it be equation number 2. So, we have area of PAB is equal to half of the area of ABQP. Let it be equation number 3. Therefore, we have area of PAB is equal to half of the area of ABCD. From equation 1 and 3, we have got this one. So, hence it is proved that the area of the triangle is half of the area of the parallelogram if both of them are on the same base and between the same parallel. Now, we have one question here. As you can see in the figure, ABCD is a parallelogram where AE parallel DC and CF parallel AD, and AB is equal to 16 centimeter, AE is equal to 8 centimeter and CF is equal to 10 centimeter. You need to find the value of AD. Here AE is perpendicular to DC and AB is equal to 16 centimeter, it is given. Now, AB is equal to CD. Why? Because we know that the opposite sides of a parallelogram are equal. Therefore, CD is also 16 centimeter. Now, we need to find the area of the parallelogram ABCD. We know that the formula for finding the area of a parallelogram is base into height or base into altitude. So, here the area of the parallelogram ABCD is equal to CD into AE. Now, you put the value of CD and AE, that means 16 into 8. that is 128 centimeter square. Again, CF is perpendicular to AD. Therefore, the area of the parallelogram ABCD is equal to AD into CF, again base into altitude. So, AD into CF is equal to 128 centimeter square, because earlier we have calculated the area of the parallelogram. So, here also we are calculating the area of the parallelogram. Now here the parallelogram is same, but we are taking different base and height. So that is why we can take 128 here also. That means here AD into CF is the area of the parallelogram ABCD, but the area of the parallelogram is also 128 centimeter square. That is why AD into CF is equal to 128 centimeter square. Therefore, AD into 10 is equal to 128, or AD is equal to 12.8 centimeter. So, the required length of AD is 12.8 centimeter. So, the next question is, as you can see the figure here, P is a point in the interior of a parallelogram ABCD. You need to show that, number 1, area of APB plus area of PCD is equal to half of area ABCD. And number 2, area of APD plus area of PBC is equal to area of APB plus area of PCD. So here first of all, through the point P, we need to draw a line which is parallel to AB or CD. If it is parallel to AB, then it is also parallel to CD. Why? Because AB and CD both are parallel. Now, for the first solution, here we have triangle APB and parallelogram AEFB are on the same base AB and between the same parallel AB and EF. So, we can say area of triangle APB is equal to half of the area of parallelogram AEFB. Let it be equation number 1. Also, triangle PCD and parallelogram CDEF are on the same base CD and between the same parallel CD and EF. So, we can say area of triangle PCD is equal to half of the area of CDEF. Let it be equation number 2. Now, adding equation number 1 and equation number 2, we have area of triangle APB plus area of triangle PCD is equal to half of area of AEFB plus half of the area of CDEF, or we can write area of APB plus area of PCD is equal to half of the area of the parallelogram ABCD. We can give it equation number 3. For the solution of question number 2, we need to draw a line through point P which is parallel to AD or BC. Why AD or BC? Because AD and BC both are parallel. Now, triangle APD and parallelogram ADGH are on the same base AD and between the same parallel AD and GH. So, we can write area of triangle APD is equal to half of the area of the parallelogram ADGH. Let it be equation number 4. Similarly, we can write area of triangle PBC is equal to half of the area of the parallelogram BCGH. Let it be equation number 5. Now, adding equation 4 and 5, we have area of triangle APD plus area of the triangle PBC is equal to half of the area of parallelogram ADGH plus half of the area of the parallelogram BCGH, or we can say area of triangle APD plus area of triangle PBC is equal to area of the parallelogram ABCD. Let it be equation number 6. Now from equation number 3 and equation number 6, we have area of triangle APD plus area of triangle PBC is equal to area of the triangle APB plus area of the triangle PCD. Now the next topic is triangles on the same base and between the same parallel. For this, we have one theorem: two triangles on the same base or equal bases and between the same parallel are equal in area. Again, we have one more theorem: two triangles having the same base or equal bases and equal areas lie between the same parallel. To understand this theorem, we will take one example. The example is that show that a median of a triangle divides it into two triangles of equal areas. The solution is like this. As you can see the figure here. Now let ABC be a triangle with AD median. Now you need to prove that area of ABD is equal to area of ACD. First of all, AN perpendicular BC is drawn. We have drawn AN which is perpendicular to BC. Now the area of ABD is equal to half into base into height or half into base into altitude. As you know, we are finding the area of triangle ABD. Now here the base is BD and the altitude is AN. Okay. Now in place of BD, I can write CD. Why? Because BD is equal to CD. So it becomes half into CD into AN. So here also half into CD is the base, AN is the altitude. Now in this case, it is the area of triangle ACD, where this is the area of the triangle ACD, where the base is CD and the height is AN. So thus we can see that a median divides a triangle into two triangles of equal areas. Now here we have one question. In a triangle ABC, E is the midpoint of the median AD. Now you need to show that area of the triangle BED is equal to 1/4 of the area of the triangle ABC. So here triangle ABC is given where AD is the median and E is the midpoint of the median AD. Now here let us join point B and E. We know that a median divides the triangle into two triangles of equal areas. So we can write area of ABD is equal to half of the area of ABC. Let it be equation number 1. Then in triangle ABD, BE is a median. Why? Because E is the midpoint of AD. So that's why BE is a median. So here also we can apply the same theorem. So we can write area of triangle BED is equal to half of the area of ABC. Let it be equation number 2. Now from equation number 1 and equation number 2, we have area of triangle BED is equal to half into half of area of triangle ABC. So half into half, that means 1/4. So area of triangle BED is equal to 1/4 of the area of triangle ABC. Now the next question is, as you can see here in the figure, ABCDE is a pentagon. Here a line through point B parallel to AC meets DC produced at F. You need to show that number 1, area of ACB is equal to area of ACF, and number 2, area of AEDF is equal to area of ABCDE. So here in the pentagon ABCDE, BF parallel to AC and DC is produced to F. For question number 1, since the triangles between the same parallel and on the same base are equal in area, so triangle ACB and triangle ACF are on the same base AC and between the same parallel AC and BF. So we can write area of triangle ACB is equal to area of triangle ACF. Then in question number 2, since the area of triangle ACB is equal to area of triangle ACF as we have proved now, so adding the area of the quadrilateral AEDC to both the sides, we have area of the triangle ACB plus area of the quadrilateral AEDC is equal to area of the triangle ACF plus area of the quadrilateral AEDC. Therefore, we can say the area of ABCDE is equal to area of AEDF. As you can see in the figure, it is very clear from the figure that after adding the area of the quadrilateral, we have got our required results. Now, the next question is, in triangle PQR, point L and M are on the sides PQ and PR such that the area of triangle LQR is equal to area of the triangle MQR. You need to prove that LM is parallel to QR. Here we know that triangle LQR and triangle MQR are lying on the same base QR and their areas are also equal. So they must lie between the same parallel according to the theorem. So that is why simply we can say LM is parallel to QR, which is also clear from the figure also. Now we will solve few MCQs. First of all, MCQ number 1. Two parallelograms are on equal bases and between the same parallel. Then the ratio of their areas is option A 1:2, option B 1:1, option C 2:1 and option D 3:1. Since the two parallelograms are on the same base and between the same parallel, same base or equal base, same thing. So their areas are equal and that is why the ratio of their area will be 1:1. That is the option number B is the correct option. The next MCQ is, if a triangle and a parallelogram are on the same base and between the same parallel, then the ratio of the area of the triangle to the area of the parallelogram is option A 1:3, option B 1:2, option C 3:1 and option D 1:4. Now, when the triangle and the parallelogram are lying on the same base or equal base and between the same parallel, then the area of the triangle is half of the area of the parallelogram. So when we will find the ratio of their areas, so the ratio of their areas will be 1:2. So option B 1:2 is the correct option. The next MCQ is, the median of a triangle divides it into two, option A isosceles triangle, option B congruent triangles, option C right angle triangle, option D triangles of equal areas. So according to the theorem, we know that a median divides a triangle into two triangles of equal areas. That is why option D is the correct option. So here we have the next MCQ. If AE is a median to the base BC of a triangle ABC and the area of the triangle ABC is 24 centimeters square, then the area of the triangle ABE is option A 48 centimeters square, option B 6 centimeters square, option C 12 centimeters square and option D 0. Now we know that a median divides a triangle into two triangles of equal area. So those two triangles has area equal to half of the area of the big triangle. Therefore, the area of each of these two triangles is equal to half of the area of the big triangle. Area of the big triangle is 24. So each two triangle will have area half of 24. That means 12, 12. So that is why area of the triangle ABE is 12 centimeter square. So that is why option C 12 centimeter square is the correct option. Then the next MCQ. Area of parallelogram is the dash of its base and corresponding altitude. Your options are option A sum, option B product, option C difference, and option D none of these. We know that the area of a parallelogram is equal to base into altitude. That means it is the product of the base and altitude. So the correct option is option B, product. So students, in this video, I hope you have understood the concepts of area of triangles and parallelograms, and also you have enjoyed all the questions we have solved today. So in the next video, I will come up with one more chapter with lots of concepts and lots of problems. So till then, goodbye.